Hello students, today we are going to see about transportation problems, and this is a topic which we have in the paper Operations Research. In that we have this unit, transportation problems. Let me explain what is a transportation problem. This paper is fully for business. If I'm running a business, that is, I'm the owner of the business, I'm producing a product, okay? So what should be my aim? I have three aims. One is to get maximum profit. If I get profit means I want to maximize the profit. In some situations, we may get loss. At that time, we want to minimize the loss. And I am the owner, that is, I am the boss of the concern. No, I have to invest some money. That also I want to minimize, that is, minimizing the cost. So we have three aims. The first one is maximizing the profit. The second one is minimizing the loss if loss comes. And whatever money I invest, no, I want to minimize the cost. These are the aims. Okay, let me come to transportation problems. Transportation problems are nothing but if I produce a product, for example, if my factory is in Chennai, I want to transport this to all over India means first I have to transport this product to different destinations in India. I may choose the main cities, namely Calcutta, Delhi, Hyderabad, Bangalore, like that I can choose. And first I have to transport my product to these origins. These places I can give the name as origins. First I have to transport there. From there I have to transport. For example, if I have transported my product to Calcutta means from Calcutta in and around the cities in Calcutta I can transport. So those places I can give the name as destinations. So from various origins to different destinations I have to transport my product. While transporting the product I have to invest some money. Namely, if I transport for transportation, I have to charge them some amount, right? I have to invest some amount that I only have to give, right? What are the three aims we have? One is to get the maximum profit. If it is loss means I have to get the minimum loss. If it is the cost means I have to invest the minimum cost. The transportation cost means that amount also me only investing, right? So I have to invest minimum. So I want to get the minimum transportation cost. So in this type of problems, our aim is to get the minimum cost. Okay. For that, we have various methods, right? First, we have three methods for getting the initial basic feasible solution. This is not the final solution. It may be the final, or we can get a solution which is lesser than the initial basic feasible solution. This one we can term as the starting solution also. Okay, so this is the beginning. We can stop there or we can still get the minimum cost. Okay, for that we have three different methods. The first one is northwest corner rule. This is the easiest method. The second one is least cost method or matrix minima method, and the third one is Vogel'S approximation method. And out of the three methods, this is the easiest one. Out of the three methods, the best solution which will give, no, this will give the best one. Vogel'S approximation method, simply we can call that as VAM, the first letters of everything, right? VAM. This is the best method. This will give the best answer. Okay. These three these three algorithms we are using for getting the initial basic feasible solution. Okay. Now come to the final solution, that is the optimal solution. In OR, this word optimal has two meanings. One is minimum, the other one is maximum. It depends upon the situation. It take any one meaning. Okay. If it is profit, means the optimum profit is the maximum profit. Okay. Profit means it takes the meaning of maximum. If it is if it is loss or cost, means it takes the meaning minimum. So general word for both maximum and minimum is optimal solution. Optimum. Okay. So in this problem, actually in transportation problems, we are going to find the optimal solution, means it is the minimum transportation cost. Okay. Maximum also we have. I will explain that in the next video. Okay. So in this video, we are going to find the optimal solution of the given TP. For that, we have only one method, that is Modi method. The expansion for Modi method is modified distribution method, or it has another name, UV method. Okay. So this is the only method which we are going to find the optimal solution. That is the final solution. Before going into Modi method, first we have to find the initial basic feasible solution, right? For that, out of the three methods, already I told you, VAM is the best method. So this one we have to apply first. Then from the solution, initial basic feasible solution, we have to further move on to Modi method. Okay. Let me explain this using a problem. Okay. Before going into the problem, in TP, we have two different types. One is a balanced TP, the other one is a unbalanced TP. Balanced TP, the definition for that is the condition for a balanced TP is summation AI is equal to summation BJ. I will tell you what is AI and BA. And if it is an unbalanced TP, summation AI is not equal to summation BJ. Let me explain about a balanced TP. In this problem, we have three factories P, Q, R and 5 markets A, B, C, D, E. Okay. And from every factory, the availabilities are given here at last 100, 120, 120. So these units means either it is a number of one single unit or a number of multiple of 10 or 100. That depends upon the person. They will fix the unit. For us, it is a unit. Okay. So from factory P, 100 units are available. And from Q, 120 are available. And from R, 120 are available. These values, the row values are A1, A2, A3. Okay. So this is A1. And this is A2 and this is A3. When we sum these three, it is summation AI. Summation AI is nothing but A1 plus A2 plus A3. When we add this, we are getting 340. So summation AI is 340 here. And what I said, the other one, summation BJ, that is total demand. Okay. In the markets, totally we have 5 markets, A, B, C, D, E. In the market A, 40 units are demanded. Okay, this is demand values, demands. Totally we have 5 demands. So summation BJ means summing the column values. So column total. So B1 plus B2 plus B3 plus B4 plus B5. Okay, so when we add all these things, this is 40, 90, 160, 250, 340. So here summation AI is equal to summation BJ. Such kind of problems are called balanced TPs. Okay. So if it is not equal means it is called unbalanced TP. The procedure for that is different. We will see that later. Okay. Now we are going to solve a balanced TP using Modi method. The problem here is find the optimal solution of the following TP, or we can say this as solve the following TP. Okay. So in this problem is given, for that availability values are there, demand is there, the inside values, everything is there now 4, 1, 2, 6, 8. For example, if we take the first cell value 4, it is nothing but the cost which we are spending to transport a single unit from factory P to market A. And this one is the cost which we spend for transporting one single unit from factory P to market B. So everything given is the transportation cost from this origin to this destination for a single unit. So the data is given and they are asking you to find the optimal solution, or we have to solve the following TP. Solve or find the optimal solution means we are going to find the final solution, not the initial one. So for that, first anyhow we have to find the starting solution, initial basic feasible solution. Okay, before going into the solution, we have to check whether the given TP is a balanced one or not. Okay, so here already we have checked this is a balanced TP. Okay, so summation AI, here summation AI is equal to summation Bj, both are equal to 340, right? This is equal to 340 and this is equal to 340. Therefore summation AI is equal to summation Bj. Therefore, the given TP is a balanced one. Balanced one. Okay. After confirming this, we have to move on to the next method. That is next step. That is the first step which we are going to use in VAM. Okay. We have to take the table given with the outside values also. What is the method we are going to use? We are going to apply Vogel'S approximation method. Out of the three methods, since it is the best one, we have to use this. From there, we have to proceed Modi method. Okay. So for Vogel'S approximation method, we have a different name also. The name for this Vogel'S approximation method is the method of penalties. Method of penalties. Penalties. Okay. Penalties. Here we are going to calculate a term which is called penalty. For every row and every column, we have to calculate that. For every row, the penalty is nothing but the difference between the minimum and the next minimum. Here the minimum is 1 and the next minimum is 2. What I said, we have to calculate the difference. Difference is nothing but the higher value minus lower value. So 2 minus 1, which is 1. Not 1 minus 2. Since it is minus 1, we are not supposed to calculate this. We have to calculate the difference. The higher value minus lower value. So it is 1 that we have to take down outside. So 1. Okay. Like that here also for every row and every column, we have to calculate the penalties. In the second row, the penalties we have to calculate. No, for that we have to take the minimum and the next minimum. Okay. So 4 minus 3, it is also 1. Then the next one is the minimum is 2. The next minimum is 4. 4 minus 2, it is 2. And column wise, 4 is the minimum, 5 is the next minimum. So 5 minus 4, it is 1. Here 1 is the minimum, 2 is the next minimum. 2 minus 1, it is 1. And here 2 is the minimum, 3 is the next minimum. 3 minus 2, 1. Here 4, 5. So 5 minus 4, 1. And last column 7, 8. So 1 is the difference, right? Out of all penalties, we have to select the maximum. So all the penalties are 1, only we have 2 is the maximum. So we have to select 2. So what is the next step? I said after calculation of penalties, we have to select the maximum penalty. So 2 is the maximum penalty. It belongs to which row? Third row. So in third row, we have to move on to the cost, which is the least cost. Which is the least cost? 2 is the least cost. So only choosing the higher penalty. There only we have to take the higher value. All the other things we have to choose only minimum. So what we have? Minimum cost. 2 is the minimum cost. Here only we are going to start our allotment. Okay. So in this 2, we have to see this value and this value, 50 and 150. So after choosing the maximum penalty 2, we have to take the minimum cost. 2 is the minimum cost. In this 2, see these two values, 50 and 120. We have to select the minimum. So 50 is the minimum. This 50 only we are going to allot in this cell. So 50 is the allotment which we are going to make. Okay. So this 50 minus 50, since we have allotted 50, no. So 50 minus 50, this will become 0. And this 120, because in this row also we made the allotment 50. Okay, so 120 minus 50, it is 70. So the balance what we have is 70. Here the balance what we have is 0. Since this value becomes 0, no further allotment we can make in this column. Only 50 units are there. Already we made the allotment in a single cell. So no further allotment in these two cells. So strike this column, because we have to make sure in the next steps we are not supposed to make any allotment in these two cells. So for that we are striking this. Okay. So after doing that, similarly we have to reduce this value also, because totally 120 units, in that 50 is allotted. So 120 minus 50 is 70. Now again we have to take the next table excluding this column. Okay, because we are not supposed to use this further, no. So without this column we have to take all the entries. So I'll draw the table. With 4 columns, right? And the cell values are 4, 2, 6, 9. The outside value is 100. 6, 3, 5, 7. Outside is 120. And 5, 6, 4, 8. Outside is 70. So 4, 2, 6, 9, 6, 3, 5, 7, 5, 6, 4, 8. Outside values are 100, 120, 70. And here it is 40 and 70, 90, 90. Now we have to repeat the same step what we did here. What we started with, we have to calculate the penalty. Penalty is the difference between minimum and the next minimum. Minimum is 2, the next minimum is 4. So 4 minus 2, the penalty what we are getting is 2. And here it is 3 and 5. So 5 minus 3, 2. And here it is 4, 5. So 5 minus 4, 1. And here 4, 5, 1. 2, 3, 3 minus 2, 1. And 5, 4, 5 minus 4, 1. And 7, 8, 8 minus 7, 1. Out of all the things, we have 2 maximum penalties, this 2 and this 2. Any one penalty we can take, okay. But for reducing the work, while choosing any one, we can take the better thing, okay. For that, if I take this 2, no. If I take this, I have to move this row. In that 2 is the minimum. 100 and 70. 70 only I have to allot, since 70 is the minimum. If I select this penalty 2, 2 is the minimum cost, and 100 and 70, 70 is the minimum. So if I take this 2, 2 is the cost, and the allotment what I am going to make is 70. So 140. Okay. If I take this 2, 3 is the minimum, and 120, 70, 70 only I can allot. So 3, 70. So 3 into 70, it is 210. We are going to find the minimum cost, no. So this is the minimum. So this belongs to this 2. So better we can take this 2. Okay. Actually, in the procedure, they didn't mention all these things. If out of all the penalties, we have to take the maximum only. But out of, if we have more number of same values, means we can take any one value. That is the procedure. But when you take like this, for example, if we take this 2, this 2 is the minimum and 70 is the allotment. 2 into 70, 140. And if I take this 2, 3 is the minimum, 120, 70, 70 is the 3 into 70. Why we are multiplying this means in the final answer, when we get the final answer, whatever allotments we made, no. While writing the final initial basic feasible solution, we have to multiply the cost and allotment. All the cost and respective allotments we have to multiply and we have to add. That's why I have multiplied the cost with the allotment make. Out of these two, 140 is the minimum cost. So better I can take this. This will help you in doing Modi method. This will reduce the steps, extra steps when we go in to Modi method. Okay. So there is no restriction in selecting this one. But for consuming time, for getting the answer easily, we can take the best of these two values. So this two only we are going to take. So in this 2 is the minimum and 70 only we are going to make. If it is 70 means this will become 0, this will become 30. Since it becomes 0, this column should not come in the next calculation. Is it clear? Now we are moving to the next table. Okay. The next table what we have is, in that we have to take 3 rows and 3 columns. Let me write the values. 4, 6, 9, 6, 5, 7, 5, 4, 8, 30, 120, 70, 40, 90, 90. Okay, the same procedure. We have to calculate penalties. So in the first row, the penalty is 4, 6. So 6 minus 4, 2. And the second one, 5, 6. 6 minus 5, 1. And 4, 5. 5 minus 4, 1. And here, 4, 5. So 5 minus 4, 1. 4, 5. 5 minus 4, 1. And here it is 7, 8. 8 minus 7, 1. So we have only one maximum penalty, 2. In that, the minimum cost is 4. 40, 30, 30 only we have to allot. Okay. So 30 means this will become 0 and this will become 10. Okay. Now we are going to cut this row. Okay. So excluding this row, we have to take the other 2 rows. So only 2 rows with 3 columns. The values are 6, 5, 7, 5, 4, 8 and the 120, 70. Here it is 10, 90, 90. The same procedure. Penalty 5, 6. It is 1. 5, 4. 5 minus 4, 1. We don't have any option. So 6 minus 5, 1. 5 minus 4, 1, and this is 1. We have more number of ones. The procedure is same. We have to select any one, taking the best thing, right? If I take this one means 5 is the minimum, 120, 9. So 120, 90, 120, 90. So 90 with the cost 5. So 5 into 90 for this one. And if I take this one, the minimum is 4, 70, 90, 70. So 4 into 70. For this, 5 is the minimum. 5 means 70, 10, 10. So 5 into 10. For this 9, this one, 4 is the minimum, 70, 90. So 70. So 4 into 70. For this one, 7 is the minimum, 120, 90, 90. 7 into 90. This is 450 and this is 280. This is 50 and this is 280 and this is 630. So this is the minimum. So better we can choose this one as the penalty. So this one means 5 is the minimum. From there only we have to allot 10, 70, 10 only we are going to allot. Cut this 10, it will become 0, and here 70 minus 10, 60. Okay, so this will, we have to delete this column. Excluding this column, we have to move on to the next step. So in the next step, only these 4 cells we have to take. Okay, so 1 minute. So 5, 7, 4, 8. And the values outside are 120, 60, 90, 90. So 5, 7 means 7 minus 5, 2 is the penalty, and 4 is the penalty, and here 1 is the penalty and 1 is the penalty. So the maximum penalty what we have is 4. So if we take this 4, and here 4 is the minimum cost, 60, 90, 60 only we have to make. This 60 will become 0, this will become 30. So we have to delete this row. Excluding this row, we have to take 5, 7, and here it is 120, 30, 90. So no further calculation of penalties, just we have to allot the balance what we have, 30, 90. 30 plus 90, 120. So it is whatever we made, no, that is correct. Everything got over. Okay. So up to this, it is called VAM. Is it clear? So after allotment, I have written everything on the problem given. I have written everything in a single table wherever we made the allotment. For example, our first allotment what we got, no. We made the first allotment in this cell. That is the second column, last cell. So on seeing that correctly, we have to write everything. After that, we can check whether we have allotted correctly. 30 plus 70, 100. The total is 100. And here 30, 90, 120 is the total. 10, 50, 60, 60, 120. Like that column wise also we can check the total. So up to this what we have got, no, that is the final thing for VAM. Okay. Now we have to write the initial basic feasible solution. Therefore, the initial basic feasible solution is equal to 30 into 4, that is cost into allotment. 4 into 30 plus 2 into 70 plus 5 into 30 plus 7 into 90 plus 5 into 10 plus 2 into 50 plus 4 into 60. That is, this is 120, 140, 150, 630, 50, 100 plus 240. The total here what we are getting is the total what we are getting is 1430. Okay, so this is the initial basic feasible solution what we got using VAM. Okay, so after this VAM is over. Modi method we will see in the next video. Is it clear?